Have you ever looked at a circuit board of an electronic device and wondered what some of those components were? Well, in this lesson, we will identify one of these components and we will learn about its properties. In our lesson titled Stay Charged, the capacitor, we introduced the capacitor as an electrical component that is used to store charges in an electric circuit. It is made up of two conducting plates that are separated by an insulator known as a dielectric. The symbol representing the capacitor in an electric circuit looks like a capacitor too. It is made of two lines with a space between them. We also learned that the measure of the number of charges that a capacitor can hold is known as the capacitance of the capacitor. This depends on three factors. First, the capacitance increases with the shared surface area of the two conductor plates. The greater the surface area, the greater the capacitance. And by shared, we mean if the plates are not directly opposite each other, the area that determines the capacitance will only be that area that is directly shared by the two plates. Also, if one plate is larger than the other, the effective area is only that of the smaller plate, because that is the area both plates have in common. The second factor that affects the capacitance is the distance between the two plates. Capacitance is inversely proportional to the distance between the plates. So the smaller the distance between the plates, the greater the capacitance of this capacitor. Thirdly, the permittivity of the dielectric between the conductor plates affects the capacitance. Permittivity is a proportionality constant. It is a measure of a medium's ability to store electrical energy in an electric field. And with that, we have the equation that relates the capacitance of a capacitor to the dimensions of the capacitor and the dielectric medium, written as capacitance C is equal to permittivity epsilon multiplied by area A divided by distance between the plates D. This capacitance is measured in farads, but for most capacitors in circuits, their capacitances are usually in the range of microfarads, that is 1 times 10 raised to the power of minus 6 farads. So we need a large surface area and a small distance to get a good capacitance. So how do we fit this large surface area into the small spaces required for electric circuits? To do this, we can change the dimensions. To increase the area, tubular capacitors are made of sheets rolled into a tube to get a large surface area into a small space. And since we're using thin sheets, the distance separating the conducting surfaces is as small as possible. These are the capacitors you might see on a circuit board looking like this. Another way to do this is to make a capacitor of many alternating thin sheets stacked on top of each other so there is a large surface area and a small gap, as you can see. This is what is pressed together to form the capacitor component you might see on a circuit board like this. Do they look familiar now? Now you should be able to explain how a capacitor works and how some are made. You should also be able to identify a capacitor in a circuit board from the shape, or just by looking at the ratings written by the side of the component. It should have the capacitance in pico or microfarads and the safe voltage of operation of the capacitor. Simple as that. See you soon.